Hi, good evening, everyone again, and I hope my screen is visible to all of you.
Yes, sir.
Yeah, thank you. Thank you. So welcome to this workshop on basically numerical computing and data handling using Numpy and Pandas. And why this is important? Because Numpy is used in entire data science ecosystem, and you as being future data scientists, it is imperative and it is very, very important to learn about Numpy. So this is a 3 days workshop in which the structure will be that today we will cover the basics of Numpy, and then tomorrow and day after tomorrow we will cover Pandas. And at the end of the workshop, we will be sharing this collab with you, and there will be an assignment based on the concepts which would have been covered during this workshop. On successful submission of the assignment, you will get a certificate for this. Okay, I have admitted him. So let's start. So Numpy is basically a numerical Python, and it is the foundation library of Python which powers almost the entire data science ecosystem. So like I said, if you are thinking of becoming a data scientist, then knowledge of Numpy is very, very important. You cannot get away without knowing about Numpy. Now, why it is known as the foundation? Because all other libraries like Pandas, Matplotlib, even sklearn, or even your TensorFlow and PyTorch, they are basically dependent on Numpy. And Numpy, what it does, Numpy library, it contains multi-dimensional array data structures, and which have got homogeneous and dimensional AND arrays and a large library of functions that operate efficiently of these data structures. So first we will see the theoretical parts so that you can answer the questions in your interviews, and then we will jump on the coding part. So like I mentioned, that other libraries are actually built on top of Numpy, like the Pandas. Pandas is basically a wrapper which is wrapped around the multiple Numpy arrays. Similarly, sklearn, when you train a machine learning model, it converts all your data into Numpy arrays for efficient computing before doing the mathematics. Similarly, in TensorFlow and PyTorch, their tensors are basically Numpy arrays that have been upgraded to run on the GPUs. Similarly, in Matplotlib, Matplotlib is a plotting library for which we are having a workshop from 16th to 18th of January. So that library also expects Numpy arrays as input to draw the graphs. So if I can say that if Python is the house, then Numpy is the concrete foundation for all your data science related jobs. So how does it work? Why Numpy is so efficient? So basically, Numpy is efficient due to the power of vectorization. What are the concept? Like the standard Python loops, they are slow. So if we are using a list, and for example, we want to make every element double, then we cannot do it like 2 into list A. We have to go through a loop. So when we do loop, those standard Python loops are slow, because Python will interpret the type of every variable at every step. This we will just see with an example. Whereas Numpy vectorization pushes the loop into a compiled C code, that everything is compiled at once, which allows the CPU to process the entire arrays at once. And this is a important thing which you can remember, SIMD, that is single instruction, multiple data. So an array is having multiple data, you give single instruction. So if I have got array A, then I can do 2 into A, and in one step, it will double the elements of that array. So that is the importance. So further dwelling into the theory, meaning of vectorization and SMD. SMD, like I mentioned, single instruction, multiple data. This is the secret weapon of modern CPUs. And only Numpy uses it effectively in Python. So like I mentioned in a list, if you have got a Python list, for example, ABC, then there is a bottleneck. What will happen if I carry out any operation on a list? So Python will fetch A first, Then it will check what type is A, whether it is an integer, float, or a string. Then it will check, does this type support multiplication? And then it will extract the raw value from the Python object wrapper, and then it performs the math. And it will wrap the result back into a Python object. Similarly, it will do for B and C. Whereas in a NumPy, so I will allow this person, he's joining, I think, from a personal email ID. I will admit. Okay. Whereas in a NumPy, we have got a similar type of data. So for example, it is like a highway. So NumPy arrays have a fixed type, example, int64. So it will not check all these steps, that what type is A, what support it will offer. So it skips all this 2, 3, 4, and 6. It hands the CPU a chunk of memory and says that multiply these next 10,000 blocks by 2. So therefore, a standard CPU operation adds one number plus one number. With assembly, the CPU will load 4 or 8 numbers at once into a special register and adds them all in a single clock cycle. So this is how NumPy becomes much more efficient. I will say on an average, it is 50 times more efficient than your list. And that is the reason that NumPys are used everywhere in the data science related field in all your computations. Okay. Now, again, going to the memory side, how does it happen? So, because this is also important point from your interview point of view, that this also may be asked. Memory layout, basically scattered versus contiguous. In list, it is scattered, that in a Python list, an array of pointers, a Python list does not store the numbers. It stores only the addresses, pointers, to where the numbers live in the memory. So all these numbers may be at a different scattered memory, and then there are pointers. So what happens? The CPU has to jump around memory to fetch data, causing cache misses. Okay, that is waiting for the data to arrive from RAM. There is a NumPy array. It stores the raw values side by side in a single continuous block of memory. So by this, what happens? The CPU fetching becomes much more efficient. And this is also known as locality of reference. So these 2 points you can note down for your theoretical answers for your interview. Somebody might ask why NumPy is preferred over list. The third important point is the memory consumption. Like data science, we know that we deal with massive data sets, and Python lists are incredibly wasteful with RAM. Why? Because in a Python integer, a standard Python int is an object. It contains the value, it will contain the reference count, it will contain the type info, and it takes up to 28 bytes, even more than 28 bytes. Whereas in a NumPy integer, it is a np.int32 is just the raw data. So it takes exactly 4 bytes. So now you can compare 28 bytes and 4 bytes. So that is the reason where NumPy is, if we have 1 billion numbers, so NumPy will require only 4 GB of RAM, which can fit in your laptop. Whereas for the same 1 billion numbers, for a list, we will require 28 GB of RAM, which will crash your laptop. So these are the basic 3 reasons why NumPy is efficient and why do we use NumPy. I have explained this. In case anybody has got any question, I'm ready to answer that. So that was the theoretical part, and that was an introduction to NumPy. Any question till now? Anyone?
Sir, is NumPy array immutable or mutable?
It is mutable. Okay.
Sir, if it is mutable, that means we can add more like numbers to it.
Okay, so we will see that. How does it happen?
No, sir, my doubt is in memory allocation.
Yeah.
Sir, like if it is mutable and we can add more numbers to it. So let's say we created one array and we did something, and after that we perform few more operation, and then we added few numbers again in that array. So sir, how is memory continuous?
Okay, so what happens in a NumPy array? For example, you have got an array with 5 elements. Okay, so when you initialize a NumPy array, it will allocate memory only for 5 elements. Is that okay? Now you want to add a 6th number. So what will happen? That NumPy array, initially NumPy array will be erased. Okay, and a new array will be created with those 6 numbers, and now the 6 memory locations will be allotted to that.
Okay,
Okay.
sir, I got it.
Okay. Yeah.
And that
Okay.
will be different from the previous five
Yeah.
memory
Yes. Yes.
locations.
It is different from the previous one. Previous one is erased.
Okay, random. That will be random.
Yeah. Okay.
And in case of contiguous,
In case of contiguous, for example, in a list, when you add one more element, so that element will be added somewhere in the memory and a pointer will be added.
okay.
Okay. Okay. So these three things, please remember from the interview point of view. Okay.
Sir, is it like a linked list?
Yeah, you can say like that.
Sir, sir, am I audible?
Yes, Satyati, you're audible.
Okay, so sir, I had one question. As of I know, Python has a global interpreter lock, so only one thread can stay active when the program is running. So, sir, how would a CPU or any machine process multiple uh, multiplications or any kind of mathematical operations if only one thread is active at the time due to GIL?
So one thread, for example, you have got a RAM, it is having 4 GB of that. So we can load that amount of data in that. And when I'm having a memory location, for example, the memory is stored from 1001 to 1010. So in a NumPy array, when I do 2 into this, so it will multiply every location by that. Whereas in list, it will go 1 to 1. It will go to that memory, it will check its type, it will come back, then it will go to second, it will come back, it will go to third. So that is the difference between the operation in a list and a NumPy. Okay. So can we go to the coding part? You can do the further studies and please illuminate us maybe tomorrow about all this. Yeah. Okay. Thank you. Thank you so much. So that was the theoretical part, the introduction part. So now how do we use NumPy? And we will demonstrate now that how NumPy is efficient than the list. So first we import NumPy as NP, and to see the efficiency time-wise, we will see how we will make a list. For example, these many numbers, I'm making a list, data list, and then we are starting a time. And for example, to multiply every element, then in a list, we have to use the loop. So I have made a loop. We will see the time. Now in a list, we cannot do data list into 2 because we know that on a list, if we do, what will happen? It will replicate. And the same operation we will do on an NumPy array, and we will see the time. Okay, now you can see, for example, by doing the loop, if we are multiplying, then list is taking around 6 seconds. And we cannot do, for example, if we in a list, we cannot do list into 2 because it will just replicate. And when we do on a NumPy array, it is just around 0.3 seconds. So this is the power of NumPy array. Whereas a list is taking around 6 seconds, it is just taking 0.3 seconds. Same we can see with the sum operation. We make 2 lists, 2 NumPy arrays, and while doing sum, how does it happen? Okay, so we can see in the list loop, it took around 0.6 seconds, whereas NumPy time is just 0.03 seconds. So these 2 examples I wanted to demonstrate just to you to show the power of NumPy and why it is used in the data science. Now we will come to how to create the arrays. So for creating the array, we pass a parameter that np.array. So if we pass a single list, we will just get a one-dimensional array. It will have just 1 row. So let's see. We have created this array. So this is 1, 2, 3, 4, 5. Class is numpy.array. Shape, you can see it is 5. So 5 means it is just a single row with 5 elements. And dimension is 1. Now, if I want to create a 5 into 1 dimension, then I have to pass this in a brackets 1, 2, 3, 4, 5. And similarly, I can create a 2-dimensional array here, 3-dimensional array, by giving the same parameter np.array. So we can see the difference. Earlier we had given 1, 2, 3, 4, 5. It was 5, 1. Here it has come 1, 2, 3, 4, 5. So we can see there are 5 rows and there's 1 column and dimension has become 2. Similarly for 1, 2, 3, 4, 5, 6. So there are 2 rows and 3 columns. So it will be 2 into 3. Shape is 2 into 3. And similarly, we have created a 3 into 3 array. 3 rows and 3 columns. So this is how we have got this. Now, somebody had asked me the question. So most NumPy arrays, they have some restrictions. For instance, all elements of the array must be of the same type of data. For example, if I am creating an array 1, 2, 3, 4, 5, then it will take, I cannot add, for example, now a string to it. For example, if I want to add Lalit to it, it will not take. First, it will try to convert that Lalit to int. And if it does not find that conversion, it will throw an error. So that is one restriction. Second is, once created, the total size of the array cannot change. The shape must be rectangular, not jagged. It means we can have 2 into 3, we cannot have missing. So each row of 2-dimensional array must have the same number of columns. Now, when these conditions are met, NumPy exploits these characteristics to make the array faster, more memory efficient, and more convenient to use than less restrictive data structures. Now, there are certain special initializations when we use. For example, we can make an array of zeros only. So for that, the command is np.zeros, 3 rows, 3 columns. Similarly, we can create an array of only ones, that is np.ones. And we can also make an range array by giving a command np.arange 0 to 10 and stack of 2. Similarly, we can make numbers between 0 to 1 and 5 values by using .np.linspace. And all these functionalities, they come handy during many data science questions or during solving the machine learning assignments. Okay, so we can see it has created a 0, 1 array, and between 0 to 10, it is stack of 2. And similarly, linspace between 0 to 1, 5 values at a regular interval. Then there is a function called np.empty. So many times we require to create an array, and its initial, when we use np.empty, its initial content is random depending on the machine state that time. What is the state of the memory? And why do we use this empty over zeros? Because using np.empty, its speed is much, much higher. And we can fill those arrays later on if we require. So for that, command is np.empty. Accessing elements of an np.array is very, very similar to list. We use the index. So
how it will look like the empty array? How it will look like?
np.arrays, for example, it has looked like this. There are 2 elements. We have given np.empty.
Yeah.
So randomly, depending on your memory size, it will create.
What is these numbers are, how it was filled? On what basis it will be filled?
These are the 10 to power 310. Okay, this is depending on your memory state.
Okay.
What is your memory state? If you do after 4-5 steps, it will give you different numbers. Okay. Now,
Sir, empty means, sir, it will delete something, or?
It is not deleting. You are creating one. See, we created np.0, for example. I want to create a random array. So we use empty. Okay. It is not deleting anything. We are not operating on any array. We are creating a new array.
In place of
Okay,
0,
okay, sir. Sir, empty means, sir, with the credential 2, I think.
2 is the,
what will say?
2 means there are 2 members, 2 elements.
Okay, 2 members. Okay.
Yeah. Okay. How do we access? So we had created one linspace array. Here we can see this 0, 0.25, 0.75. So we access as we access in a list. So if we access, for example, 0, it will give the index 0 element. At 1, it will give first element. Now, the question of mutability. So I will show you certain examples, like I had mentioned. So we have got linear space array, which has got floating points, 0, 0.25, 0.5, 0.1. Now, if I want to mutate it, I want to change it to Lalit, it will throw an error because it will take only an element of similar type. So I will just demonstrate that. So if I add Lalit, so first it will try to convert Lalit into float. And if it has not been able to change, then it will throw an error. So you can see the error could not convert string to float. Okay. However, if I, for example, I mutate 0 to 100, so can somebody tell me what will be the first element?
100.0.
100.0.
Yes,
Zero, sir.
very good. So, okay, so it has added, for example, 100. Okay.
Can't we do this linear space error with the element having the integers only?
Can you come again, please?
Linear space array elements can be integers only instead of float. Can we define in that?
I don't think so. If you are giving, for example, 0 to 1 and you are asking 5 numbers, so they will become float only.
If you put 0 to 100 with a step up to
Sir, can we convert them into integer by coding, code by code? Can we?
Yes, it can be done, but let's check again. Why to wait for that? Okay.
By default, it is every time a float only, right?
So let's see. So this is a float. Okay.
always it will be float.
Yeah. Now there are other things which are view and copy. So till now everything is clear. How the Numpy arrays, how we are adding, mutating, non-mutating. Any question till now? Okay, so I'll take that. So there is a thing called view and copy. When we say, for example, if I make, for example, I just say B is equal to, I'm accessing one element and I say B. So this is a view. If I change, for example, this value, then it will mutate the original array. For example, if I'm making we have changed our array, I think so. So when we see linear space array, for example, array we are accessing the element, it is default by view. And if I change some element, then it will mutate your original array. It is similar to your Pandas data frame, that if you don't copy and if you take a slice of data frame, you change some values, so it will mutate your original data frame also. Same thing is applicable in Numpy. Like I mentioned, your Pandas is a wrapper on Numpy. So you see here, B0 we have changed to 55, and when we have printed the original array, so it is 55. So if you want to make a slice, a different slice, we have to use the copy. So it is very, very similar to what do we do in Pandas. Is this clear to everyone? View and copy, and we can relate to Pandas. So when we'll come to Pandas, we will see it there also. Now similarly,
what was the difference between the copy? What difference it could make?
In the copy, for example, you see here we have made a B. So here we have got original array this 55, 25, 50, 75, 100.
Yeah.
Now once we have copied and we have made B0 is equal to 33, you print B, it will be 33, 25.
Okay,
And
original will be kept.
Original will remain same, and this is a very, very important concept in Pandas also. And we have to remember this when we are doing the computation for our machine learning models, because there we often make this error. Okay. The same thing comes the memory semantics when we do ravel versus flatten. So an array can be flattened using two commands. One is ravel, one is flattened. So ravel is like similar to view, that when you ravel the array and if you make any change, then it will change your original array. But when you flatten it, so flatten makes always a new copy and it will not affect your original array. But flatten, like your copy, it will use more memory. So we can take an example. I'm creating one array, or 2 rows, 2 columns, and then we do ravel, then we change the 0 to 99, and then we can see what happens to your original array. So here we can see 1, 2, 3, 4. After ravel, it becomes 99, 2, 3, 4, and your original matrix has also changed.
Ravel is a function.
Ravel is a function. It just flattens.
Okay. Flatten is also a function of flattens.
So that is the difference. That is the difference, that after ravel, if you make a change, it will change your original array. If you do in a flatten, then it will not change your original array.
Okay.
Okay. So you can see here, when you flatten 1, 2, 3, 4, original matrix, again, you have changed to 99, but your original matrix has not changed. It has remained 1, 2, 3, 4. Whereas your flattened matrix has changed 99, 2, 3, 4.
Yeah.
Okay.
Yeah.
Now, as we know, we can have the arrays of different dimensions. We can access them by specifying the index along each axis within a single set of square brackets. So, for example, if we create a 3 into 3 array, and I want to access, for example, 0, 2, what it will mean? It will mean first row and second column, the third column.
Third column.
Third column. Here it is second row and second column. So it is very similar to list. It is only in happening in
3, 5, yes.
more dimension. Okay. Now
Once again, we go to the ravel. What we did in the ravel, just
we will share this collab with you.
okay, fine.
Okay. So ravel is only that it flattens, but when you make a change, it changes your original array also.
Original also, right?
Okay. In flatten, when you change, it does not change the original.
Okay.
Okay. So you can relate it. Ravel is like view and flatten is like copy. Okay. Now, when we come to broadcasting and operations, this is the most, used operation and which makes NumPys very efficient. So what is the meaning of broadcasting here? Basically, the broadcasting means when we are performing operations on arrays of different shapes. For example, if we create 2 arrays, A and B, so we can carry out A plus B, it will computationally, it will sum up, which we had seen during the demonstration. If we do A into 2, it will broadcast, it will multiply every element by 2. Similarly, we can multiply by 3. Similarly, your matrix multiplication, which is there, it is very computationally efficient. So for matrix multiplication, if we are doing a dot product, we can use 2 commands. Either we can use np.dot, giving first array and second array, provided that these 2 matrices are fulfilling the conditions that multiplication can happen. Or we can use mat A at the rate mat B, it will also do the dot product. So we can see these functions. Now there is another function where...
Hello, sir.
Yes.
Sir, for the dot product, the 2 matrix should have same shape actually.
No. At what stage of the program you are?
Hello, sir.
At what stage of the program you are?
I mean in diploma level.
Can you multiply 3 into 4 into 2 into 4?
No.
3 into?
3
No,
into
sir.
4 into 2 into 4?
No.
Can you multiply 3 into 4 into 4 into 3?
Yeah.
So their shapes are different, 3 into 4 and 4 into 3.
Ha.
So your statement was incorrect.
Okay.
Okay.
Yeah.
Your column number and row number, the column number of the first matrix and the row number of the second matrix has to
Second
match.
should be same. Yeah.
Okay, so you can multiply 3 into 4 into 4 into 2, which will give you 3 into 2 matrix. Okay. Yeah. Okay. Now there is a command called reshape. What it can do, it can change, it can give a new shape to an array without changing the data. But remember, when you have to reshape, then that shape has to have the same number of elements. For example, I prepare a array A, which will have 6 elements. Then I can convert it into, for example, 3 into 2. So it will have 3 rows, 2 columns. Similarly, I can reshape it into 2 into 3, 2 rows, 3 columns. But if I'm having 6, I cannot have 4 into 2 because I don't have so many numbers. So this reshape is also sparingly used in machine learning assignments, or some tasks they come where you have to reshape. So that is the command, reshape. We have also commands like not used very often, np.newAxis and np.expand dims. They are used to basically add a new dimension. So if I'm having an existing array and I want to add one more dimension, then we use this. So I will give you a demonstration for this. We had made an array, this np.arange6. So if I want to add, for example, an axis, so see, these are the points 0, 1, 2, 3, 4, 5. Its original shape, we can see it is just 6 elements. It is a single dimension. I add a new dimension here. So in this new dimension, if I use it after this, like np.newAxis, after that slash, it will add a 1 row and it has got 6 columns. So this has become single row, 6 columns. Again, I add 1 more dimension here, then it will become 1 number, 1 row and 6 columns. So that's how I can keep on adding dimension to an array.
Pardon, sir, once again, I could not get it.
So I will just show you, I will give you from here example.
No, please.
Okay, so for example, is my screen visible?
Yeah, visible.
Okay, so I'm having this array 5, 6. So this, what is the shape of this? Is 6 this?
6.
Okay, now I want to add 1 dimension. So when I add new axis and slash, then what it will do, it will add 1 more row. So this will become 1, 2, 3, 4, 5, 6, 1 row and 6 dimension. They will come inside this 1, 2, 3, 4, 5, 6. Okay. Now add 1 more new axis, again slash, then it will become 3 dimension. So this is 2 dimension, this is single dimension, this is 3 dimension, and here it will become 1, 1, 6. Okay, and like I mentioned earlier, this is not used so frequently, but this is one thing which can be asked. Now, same thing we can do. For example, here we had used np.newAxis. Here we have done after for array. If we use this slash before, then it will add columns.
Slash or colon?
Column. Okay. So here we can see, here it had happened. So we are using now before that. So it will add columns now. It will give 6, 1, 1. So here it was 6, then it become 6, 1, then 6, 1, 1, and then it can further go on. Same thing we can do by using a command called np.expand dims, means expanding dimension, and there we can give axis. So here we give axis is equal to 1, and here we give axis is equal to 0. Now I will ask anybody, can somebody answer what is x is equal to 1 and x is equal to 0? We have used in our MLP project.
X is equal to 0 is
So
column.
one talks about the rows and other talks about the columns.
X is equal to 0 is for column.
0
and
is
X
for
column.
0 is for column and x is
0 is
1
for
Column.
0 is for
Row.
rows, I guess.
column.
0 is for rows and 1 is for
Column.
column.
okay. 0 is for okay. Now we come to indexing and slicing. Indexing and slicing is very, very similar to Python list. How can we do? Like from 0 to 2, it will start from first element, it will go till third element. If we start from first element, it will cover all the elements. -2 from the end, it will take the second most and then will cover all the elements. So this is very, very similar to your list operations. Now this NumPy arrays, they have got a good functionality that you can choose elements by fulfilling certain conditions. And this comes handy during your Panda operations also. When you are having data frames, you can select with some conditions. We will see in Pandas, the same concept is used. So for example, I have got an array. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 3 rows, 4 columns. And I want to select all the elements which are less than 5. So I select A and bracket A less than 5. So you can see this is very, very similar what we do in Pandas. So we select a data frame. Inside that, we put the data frame and the condition. So when we do that, it will select all the elements which are less than 5. Similarly, we can select all the elements which are greater than equal to 5. It is same. We can give condition and put condition inside the bracket. It will give the same result. These are certain things which we use very, very often during our machine learning computations. Whenever we are doing modeling for machine learning models, in Pandas data frames, these kind of things we use very, very frequently to find elements which are fulfilling certain conditions. Similarly, if you want to check all the elements which are divisible by 2, so I have given a condition and print that, so I can get all the conditions. So I have done in 3 ways. Please see this. In first, I have given A, bracket A less than 5. In second, I have given the condition, then I have put condition inside A. Third, I have found the answer and I am printing that. So all the 3 things in that I can do. I can also use AND. So I can find all the elements which are greater than 2 and which are less than 11, and it will give. Similarly, I can give OR also, which is a logical operation. It will give me true, false. A greater than 5 or A equal to 5. So this is a logical operation. Okay, then there is a sorting. In NumPy, we can do sort, and the parameters are, we have to give the array, which is A, then we give access, then we give kind. In kind, we can give all kind, quick sort, merge sort, heap sort, what we have learned during our diploma PDSA. We can also give order. Order means string or list of string. It is an optional. And stable is equal to none. Stable is a bool. It is optional. We want to say that sorting should be stabling. So important here from the theoretical point only, or from your interview point only, if you are asked a question on NumPy sorting, you should be knowing only this kind which is there and the axis, that it can do sorting along the column axis or it can do the row axis.
-1 axis means?
-1 will come, your default behavior is, just hold on. Okay. So when you do axis is equal to -1, this is basically axis is a -1 horizontal, that is the rows. Okay. So axis is equal to 1 or -1, then it is a default and it is a 0 rows. And if you specify axis is equal to 0, then it is a vertical direction, column wise. Okay.
And 1, what is the difference between 1 and -1?
1 and -1 is for rows. Both are used for rows.
Okay.
Okay. Okay. So we can see, for example, there is an array. We had made an array. Let's see where is that array. How does it look like? So this was an array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, when we don't give any access, then it will do how it will sort. It will sort your row wise. So it has sorted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has sorted. If you do column wise, it is already sorted column wise 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12.
Sort will automatically flatten it.
Yes, yes. Okay.
Okay.
So when you set axis is equal to 0, basically you're telling NumPy to sort vertically column by column. And if you're not giving anything, for example, then it is doing the row wise. You can also sort when you tell them values, and for example, you make, for example, here, you can give an order. So for example, I have got an array here. I have got these values. I will print this array, for example. And when you sort, you give the array and you can give order that in which order you want to sort this. So this thing, it comes handy during our machine learning models. When we get a data frame and we want to sort it, for example, by some column, then we can sort that data frame by giving that column name. So before that, you have to convert that Pandas data frame into an NumPy array, and then you can sort it, and then you again can convert it to Pandas.
So pardon, sir, once again.
In Pandas data frame, you have got columns.
Yeah.
Okay. Now, for example, I want to sort a data frame by a column values.
Yeah.
So I can convert that Pandas data frame into a NumPy dot array. And then
that particular column only.
Not that particular column. We can change that entire data frame into NumPy dot array. And then I can use np dot sort, and I can use that order of column. Otherwise, in Pandas also, we have got a function for that we can sort a data frame by a column value. Okay. But in case you forget that, and basically that is a wrapper of this np dot sort.
Sir, in this course, yes, sir. Sir, in this workshop, are you going to discuss about the Pandas also?
Yes, yes. So today we are covering the basics of NumPy. From tomorrow, we will start Pandas. We will have 2 days only on Pandas.
Okay, sir. Okay. Thank you.
Okay.
Sir, can you explain, sir, one small thing that in the printed section, there is written D type equals to name, then U10, F8, and I8. What are those, sir?
These are, I'm giving, for example, U10 means it is a Unicode NumPy array. When you give a string, for example, I write Lalit, L-A-L-A-T. So it is a Unicode character, and the 10 means the length of that it can take a string up to length of 10, Unicode 10. When I'm saying height, I'm saying it will be float type. When I'm saying age will take int values. Is that okay?
Okay, and sir, the lesser than sign, is that holds any significant value or meaning?
Which one? Which one?
Sir, before the I8 or F8, there is a lesser than sign.
Where is the lesser than sign?
Sir, in the D type is equal to in the output section, sir, he's saying.
This U10, no? Here. Okay, this is the int 8 means int, and it is taking the 8 memory values. Okay, it is like F16, 8. Are you understanding what I'm trying to convey?
Yes, sir, thank you. I'm just saying there is a small lesser than sign before that, before the I.
It is just, no, it is not lesser than that. It can take maximum U10. Name, it is less than U10 means it will take all the names which are less than equal to U10.
Okay, sir, thank you. But sir, what if there are any new customers or new dataset where there are names which take more than Unicode 10 or?
Okay, let's check that. For example, if I increase this, for example, ADHKL. Okay, I will increase it.
It will cut short.
So let's see that. Okay, so it has cut short. It has taken maximum 10 only. Okay.
Okay, sir. Thank you
Sir,
very much.
when we initiate using a float type, does it default to only 8 characters like here?
Yes, yes. We can see here.
Sir, can we change that?
Yes, yes. Please find out. Please let us know tomorrow. Okay. That is a homework for you.
Okay, sir.
Yeah.
Okay, sir.
Yeah. Okay. Now there is a V stack and H stack. It is not used so much, but it is like vertical stack and horizontal stack. Like we do the concatenation. We have learned that. So if we have got two arrays, then we can do the concatenation by using vertical stack and the horizontal stack. In the vertical stack, it will concatenate vertically, and in the horizontal, it will concatenate horizontally. So we can take this example. We are creating two arrays, two rows, two columns. Let's see. And when we do vertical stack, it will concatenate vertically. And now, for example, if I change a value of 0, 1, and we are printing, so A1, A2, it has come, and print B. So here we can see when we are changing the value, your earlier arrays which were there, A1, A2, they have remained the same, but your concatenated one, it is different. So what is the meaning of this? It means when we are concatenating, it is producing a new array, which is different, and it is occupying a different memory. So it is not affecting your earlier arrays. Similarly, if you do the H stack, then it is doing the horizontal concatenation. We can see that. We also can split array into several smaller arrays, and for that command is hsplit. It is generally not used in machine learning or data science domain, but I just wanted to cover it just for the sake of completeness. So for example, we make an array 1 to 25, and then we reshape 2 to 12. It has taken the 24 values, so we have got two rows of 12. Now, if I want to split it, so command is x3. So it will split it into 3 equal parts. So it has split it, for example, first part, second part, and third part. We also
number of splits should be compatible with that.
Yes, yes, number should be compatible. So I also can split into x, for example, 3 into 4. So what is the meaning of 3 into 4? Can somebody tell me?
3 rows and 4 columns.
3 rows and 4 columns.
Yes, yes. Okay, so it will split. So addition, subtraction, multiplication, division, it is very, very similar to your list. It is handy. Only the thing is that the computationally, what we demonstrated earlier, it is super fast because it is happening in one go. Okay, so we can just see this is addition, just we are adding, we can directly do that. Multiplication, subtraction we can do, multiplication we can do division, we can divide the entire array, and super efficient. This is there, then dot product is there. We can find the sum. Okay, we can find the sum also along the column by giving x is equal to 0, along the horizontal by rows x is equal to 1. So it will give. Now these are self-explanatory. We can find maximum, minimum, sum, mean, product, standard deviation by using the commands like in the list we use max, min, mean, std. So it will give.
Can you just show the sum part once?
Okay.
Oh, sir, in x is equal to 0, it is summing. No, so just go down.
So this we had made, okay, for example, data is equal to array 1, 2. And when we do the sum.
So in x is equal to 0, it is doing for the rows, right?
Just hold on. This is 1, 2. So this is sum is happening column wise. When your axis is 0, 1 plus 5 is 6, 2 plus 10 is 12.
Oh, why not?
So 1 plus 5 is 6. Now it is happening column wise. Now it is happening vertically. Got it? Hello, I hope it is clear.
Yeah, it is.
Okay. So this maximum, minimum, this is just. Now we also, there is a very important function which we use in data science, which is generating random numbers. So you might have seen during your MLP project or somewhere else, in our, when we have to generate the random numbers, we always use the np.random. So we give default range. So the simplest way to generate a random number, just np.random and give default range. It will give, depending on your memory state, it will give. So,
random state will work here also, random state.
Yes, yes, it will work. And we also can give, for example, in the range. Now I can give, for example, it has created. Now I can give integers 5, size 2 to 4. So that will give. Okay, so it will give from 1 to this 5, 1 to 5 maximum. Then there is a
generator, it is telling.
This is a generator. When I'm giving a default range which is there, this is a generator. Okay, this first command. And from there, I'm generating, for example, 3 numbers. So this generator is generating these 3 numbers.
This np.random.default RNG.
Yeah.
Default RNG is a function of
It is
random.
a function which is creating an object of generator class.
Okay, generator is a class. Okay.
Yeah. Object. Generator is an object.
Generator is an object of this random class.
Yes. Default range.
And PCG64 is what?
It is the name generator. Okay.
Name of the generator.
Yes. Okay, then we have got np.unique. We can find the unique values from an array. We can find occurrence count. These are generally used in Pandas in a different way. We will see that in Pandas. We also can transpose and reshaping a matrix. The command is a.t. So when we have got a array, for example, we have made an array, then we have reshaped it to 2 rows, 3 columns. We reshape it to 3, 2, it can be done. And we also can do the transpose of this. So we convert it into 2 into 3 and transpose. So we get that. So command is .t. So any array a.t. We also can reverse an array. The command for that is np.flip. So we can see, for example, we have made an array, and if we flip it, we get a reverse. So this is, you can use. Okay. Now you can also flip along the axis, either the column axis or the horizontal axis. So for that we give axis. Okay. Now just wanted to tell you, for example, somebody had asked the type of arrays. So I will define, for example, array 1, which is having numbers. I will make an array of string where it makes a Unicode, and depending on the length, it will get that number. And now I will try to use, for example, make an array Lalit 150. So can somebody tell me what will be array 2? Will it throw error or it will make an array?
Sir, it will make 100 but in string. I mean,
yes.
In lexicographical order.
Yes. So the 150, they will be Unicode objects here. They will not be integer or float. So it will create. Okay, so that is the difference. So we can see 150, they are object types. Okay, and you can see by typing the D type. So here it has given U5 and U2. So U5 is meaning that it can take up to 5 things. So array 20. Array 20 is, you can see Lalit. So it is taking 5 characters. That's why it is U5. Whereas array 250, it is taking 2 characters. That's why it is U2. So that is the Unicode of 2.
We are checking here the individual elements data type.
Yes. So they are known as Unicode. If you are asked a question in some interview, that if there is a string, what is the data type? So it is a Unicode. Okay.
Sorry.
Okay. Yes. Any question?
Yeah, the 100 and the 50. So it gets converted to like string type.
It has converted to string type, and in string in Numpy array, we call them as Unicode.
So basically, the preference is higher for the string type, right?
No, it is like that I cannot make an array of different data types. Either I can make an array, for example, I make an array. I will just give you an example here. For example, SKP, I make an array 1 is equal to NP dot array I give, for example, I give 1.1, 2, 3, 4, and I type, for example, array 1. So what will come here? Tell me. What should come here?
1.1, 2.03.
Okay, there is a mistake I have had here. So everything will get converted to float because your first is float.
Okay, so
No, if the first one is integer, second one is float, still it will be float.
Still it will be float. But here,
Because
for
the
example,
float will be preferred.
but
out
here,
of the
for example, I give Lalit. So now what
Then
it
it-
will become? Everything
Unicode,
will become to Unicode now.
Unicode will.
Okay. So this is the difference. Okay.
Sir, in the generator
One-
class, what is the range?
One more question here, sir. Unicode, in case of Unicode, sometime it is saying U5, sometimes it is U32. In what case it will decide on what
Okay.
basis?
Okay. So for here, the float has come 1.1. That's why it has taken 32. If I remove this one, for example, this has become 21 for integer. If I take
On what basis it is deciding?
it is giving memory. For example, when you make a Numpy array for integers, it gives that memory that I will take of this size only. But for example, if I make it here CMA, then it will give U5 because it will occupy only 5 memory locations. I increase it to, for example, Seema Kumari, then it will take 12. So it is depending on your memory. It means when
it will take maximum one.
maximum
out of the,
maximum one.
Okay. In case of integers or like that, it is taking more memory.
Yes.
Okay.
Okay. So with that, I have finished this part. I will add something in your G space. There are certain functionalities of
One more
Numpy.
question, sir. It means strings memory is less than the integers or float.
No, string memory will depend on the length of your string. For example, if I increase
maximum length of.
Yes. Okay.
Okay.
Okay. So what is happening when you're initializing an array? Array is making memory depending on the requirement. Whereas in case of float and integer, it is giving fixed one.
Okay.
Okay.
It is defined by the bytes, right?
Yeah. Okay. So with this, I have finished with most of the numerical operations of Numpy. I will send some functionalities which are done on strings that I will add on the G space. So this is for the ones who want to dwell more into the Numpy. But I am keeping the focus of these workshops basically on the data science, functions. What are the things which we use in the data science? With this, I have finished. If there is any query, we can discuss, or we can complete, or we can finish day one.
Sir, about the assignment, sir, can you give us an introduction about what exactly we have to do in the assignment?
Okay, so in assignment, what will happen? So whatever we are learning during Numpy and Pandas, we will give you one data set, and we will ask you to carry out the functions of Numpy and Pandas to find those things. Okay. So this will be like a hands-on assignment, like we have done during our MLP project, or any data set which we get, a real world data set that we'll give it to you, and we will ask you to find those certain values. Okay, we might ask you to find the median, we might ask you to find the mode, we might ask you to correlate.
Just like MLP milestones type questions.
Yes, so but they will be covering all the concepts, whatever will be covered during this workshop.
Okay, sir. Okay. And sir, what the exams that is mentioned?
Exam
So
is not there.
dated.
So there is no exam. You have to submit only assignment.
Yes, sir, about the assignment, sir, will it be on the course portal, or we will have to...
No. So what we will do, we will release the PDF, we'll send it to all of you, and we will give you some time, for example, 3 to 4 hours. And within those 3 to 4 hours, you have to submit the forms. Is it okay?
Can you tell the approximate date, like when it will happen?
Okay, so today is 6, we are having 7, 8. So on 9th, we will release the assignment. We'll give you around 3 hours. And within 3 hours, you have to submit the forms.
So we will be sharing it.
Uniform type of thing.
Yes, everything will be shared with you. Okay.
How do I access the G space?
How to access the G space? G space, I have added all the students who have registered for the workshop.
I have not used G space in my lifetime. What is it? You explain.
Okay. So you can ask one of your fellow students. Okay.
No, I will not. I have come to this workshop. I've registered for it. So you have to explain it to me.
Okay, go to the
What's your good name? Yes. What's your good name?
My name is Jatin Banerjee.
So Jatin Banerjee, you feel so entitled that you have joined this workshop, so I have to explain to you how to join the G space. So that is not the intention of
No,
this.
I have not. So you are using some tools which I have not used. So you can use common tools like Google Docs or something, right? Which everybody uses. I have not used G space.
So this is your assumption. I will leave it to you that you are assuming that everybody uses Google Doc. If you have not used, so don't assume. You can kindly request. You can make a request. We'll help you.
GSpace is a thread.
Tell me where is the GSpace link? How to access it? You have not given any background.
So do you have Gmail account?
Yes.
Please go to your Gmail account.
1 minute. I'll do that.
Share your screen, please.
Okay.
Please share your screen.
1 minute.
Sir, this file you'll be sharing today?
This file we will not share. We'll complete it because during the journey, maybe we will be adding some more components. So once it gets finalized, we will share this collab on 9th with all of you.
But it's not beneficial. So you share, we will practice it or not so that we can proceed. Maybe you change it, we will do it again, no problem. Because it is required, sir, for practice. You are so fast.
Okay, let me see. So this part which is there today, what we have covered, this I will share tomorrow morning.
Yeah, no problem.
Okay, I have shared now. Can you see?
Thank you, sir.
Just hold on.
Yeah. Hello?
Yes, just hold on, please. Okay. So please click on chat, okay?
Chat?
Chat, yes.
Okay.
So chat, okay, you can see Numpy Pandas W.
Yeah.
Click on this.
Yes.
Below Kaziranga.
Yeah.
So this is your G space. You can see now everything.
Right. But how do I submit my assignments?
So that okay, you will receive an email with a form, and through that form you will have to submit.
Okay. And you will post the assignment here itself?
No, I will send the assignment via email to you, all of you.
Okay. And the recordings, links, and everything you will be posting here, and the
yes. That also I will send the. See, G space is a medium to share the information. However, when time elapses, then it is very, very difficult, or it becomes cumbersome to find those things. So the important announcements, important everything will be sent by email.
Okay.
But certain announcements, certain things will be shared by the G space also.
Makes sense. So one thing, so see, you said that you will post it on 9th, right?
Yes.
Okay. So you and then within 3 hours we have to submit the assignment, right? 9th is a Friday.
Yes.
Right. So you please give us some advance time, that what time, because then we have other work. No? So if you can give some advance that this time I'll post, you submit the assignment at this time. That will be useful for us.
Yes. So what I can do, I understand a lot of students are working professionals here.
Yes. Yeah, same here.
So what I will do, I will release this assignment maybe in evening.
Okay. That is good.
Okay, I'll release it around 7 o'clock, and by 10 o'clock you can submit that. And
all right.
Okay,
I'll stop sharing then. Okay.
Yes. So mine is shared.
Sorry to interrupt, sir. In the workshop panel, it is said we have an exam on 11th of Jan.
Yeah. Okay. So Khushi. So that exam we are not conducting. We are giving you a assignment.
Okay. So that exam was different from these assignments, right?
this is same assignment, but we understand that, doing on the portal, the basic objective of this workshop is basically to tell you why Numpy is used, why Pandas is used. We have been using as a student during diploma, during degree, but know those nitty-gritties, okay? And to cover from data science field point of view, that if you are asked questions maybe during interviews, then you are able to answer them. Okay, and this Numpy concepts will come handy to you when we will be covering Pandas data frame. Okay, how we do the data wrangling, how to find the data using the Pandas data frame, because in all our data science field we'll be using Pandas.
Okay, thank you, sir. So we can ignore that 11 and exam other stuff.
Yes.
Thank you, sir. Just one last question. Can you kindly specify that in the exam or assignment, what will be the pass percentage? Or I mean, how much marks we have to achieve to get the certificate?
I will say around 60% you will have to score.
Okay, sir, thank you.
Yes.
Okay, Acharya ji, see, I began my career in 1995. So that time we had C and C++. So there we had a concept of shallow copy and deep copy. We used to do it, I mean, as you know, C is very near to the machine architecture. So I believe that during your talk, I mean, since you are mentioning interviews, people will also like to know whether the student has got that architectural view of the computer or the board when they are saying that, okay, when you do a copy, then the array changes. Then if you do if you, in certain types of copy, the array doesn't change. Okay, when you change this thing. So I think that concepts also will maybe help when you give that connection.
Yes,
you know.
Then thank you so much. So for Numpy, I have covered that. Again, for Pandas, again we will be covering those concepts.
Today we are doing something more.
No, today we have finished. Okay, this is the Numpy part. We have finished. So if there is any, yes, Shweta.
So when will we receive access to the training portal?
To the training portal. So you are talking from the training point of view?
Yes, sir. Training and placement.
I think from today onwards, emails have started going, and the students are being allowed to access the portal. So maybe by tomorrow evening, all the students will get access.
Okay, thank you, sir. Okay.
So I didn't guess. Sweta, I didn't. I have everybody got the this thing for the training portal. What do you call that link?
No,
it has
not
been shared by all diploma students or only
So
to
like,
BSc students?
Atin, are you registered for the training?
Yes.
Okay, so like I mentioned, we are issuing those emails. They are going one by one. So maybe by tomorrow evening, all IIC registered students will get access to the portal.
Okay. All right.
Yes. Yes, Prashant.
Sir, in the code you mentioned generators. So what is the range of values?
Yes, we will check. Please check and please tell us tomorrow. Okay.
Every session will be 1 hour only. Tomorrow.
1 hour, yes.
Okay. And I will request that if you share for the exam link and the code, please kindly give not the 6 evening time, because it will be very difficult for us who are in the office. Either go after 8 p.m. or before that.
Okay. Okay. So
because 6 to 7 is critical time to transit.
Okay. So we will deliberate. Don't worry. So
yeah,
objective is basically learning. Objective is not making life uncomfortable for anyone.
Yeah, that's why I'm asking just.
Okay. So we will consider that and we'll give you more time. Okay. Yeah. My request is that whatever assignment you're doing, please solve through the learned concepts. Okay. In the current world, you can solve everything through LLMs or ChatGPT, but please try to follow those concepts and try to find answers. Because especially for freshers, many interviews you are asked to write code. Okay, so you should know how to find something. Yeah, Shreya, please.
Yes, sir. I was saying that on 9th evening I have another workshop. So and attendance is mandatory.
Okay, Shreya, we will consider. Don't worry. Okay. Don't worry. We will give you enough time. Yes, Tamal.
So my query is regarding the recording. Actually, today I have joined little late, around 6.
Yes, so this session is being recorded.
Yeah.
And once the workshop will be over, we will share the links with all the recordings.
So it is my humble request if you share the workshop like recording everyday basis, then
okay, we will consider.
If someone misses the class or joins late, then
Okay,
it will be helpful.
understood. So as soon the recording becomes available, we will send.
Yeah.
Collab also, sir, today, because we will.
Collab may be better. Collab I will share tomorrow morning.
Yeah.
So that
tomorrow morning. Okay, fine. Thank you.
Yes, Rasika.
So regarding the assignment you have said, would it be relatable to similar to the MLP OPP?
So Rasika, it will not be in MLP
because in MLP OPP we use pandas a lot.
Yeah. So in MLP OPP you had done a lot of things: scaling, training, testing, splitting.
Yeah.
Okay, finding outliers, modeling, tuning hyperparameters. So it will not be like this. The assignment will be primarily using Numpy and Pandas for data basically wrangling.
Okay.
Okay, so it will be much less evolved than your MLP project.
Okay, sir, I get it. Thank you.
Yeah. Yes, Fazal.
So you are taking another workshop called data visualization using Matplotlib.
Yes,
I've also enrolled for that, and the timing for that is also clashing with the Git workshop on the 19th.
Okay, so you are doing Git workshop also?
Yes, sir.
Okay, so we will take some decision. In case there is a conflict, we will change the time.
Yeah, timing for the data visualization is given from 6 to 8, and the Git workshop is from 7. That was
okay. So we will change the time. Don't worry.
Okay, sir. Thank you.
Yeah. Yes, Ravish. Hi, Ravish.
Yes, sir. So you mentioned that you will also share some extra material of NumPy on operations on strings and other data types.
Yeah, that I will send.
Okay, sir. Okay, thank you.
Yes, Preeti.
So my request also is similar to the other person's request, sir. The collab, as soon as possible, you can share. It will be easier for us to practice.
Yes. So by tomorrow morning, I will share this collab, whatever we have covered till now.
Okay.
And in the same collab, I will share those string operations also.
Okay, sir. Thank you.
Okay. Yes, Prashant.
Sir, I have actually I registered for this workshop using the workshop portal, and I had done the payment, and I got that payment successful message also, but I didn't get this Gmeet link as well as that GSpace access. So I got this Meet link through one of my friends actually, but I had paid for this workshop.
Okay, so don't worry. Till the time you are able to join the link and you send me, can you write your email ID? I will just add you. Write in the chat.
Yes, sir. Yeah. Sir, I have also sent a mail to you.
Okay, you can just write in the chat. I will immediately join.
Yes, in the chat also.
Okay, thank you. If there is no further query, we will close this today. So today we have covered NumPy. So we started with the introduction. First of all, we covered why the NumPy is so efficient and why the NumPy is the foundation. Then we learned how to initialize the different types of NumPy arrays of different dimensions and to carry out different operations using NumPy. I had left the string operations that I will include in the collab, and by tomorrow morning I will share this part. So tomorrow we will start with Pandas, and tomorrow and day after tomorrow we will be dealing with Pandas, because the Pandas is the one which we use during our machine learning all kind of projects. But before knowing Pandas, I thought that we should know NumPy, because the NumPy is the workhorse. It is a foundation on which the Pandas is the wrapper. Thank you so much. Thank you for joining. Have a very nice day.
Thank you. Thank you very much.
Thank you, sir. Great experience.
Good night, everybody.
Be able to join this workshop. Thank you, sir.
It was very